Hello, this is Mr. Taylor with Young Engineers Today. This is a recap of the 5th and 6th grade webinar on Monday, September 14th, 2015. All right, we are going to talk about aqueducts and tunnels. Aqueducts. The definition of an aqueduct by Webster is a conduit for water, especially one for carrying a large quantity of flowing water, a structure for conveying a canal over a river or hollow. Innovative engineering by the Romans. Okay, this is a video. I will have the link posted in Edmodo for this video. Aqueducts were created by the Romans as the Roman Empire grew. And they developed this extensive system of aqueducts to deliver surface water by gravity on a gradient to cities. As the cities grew, especially in Rome, the city grew and the Tiber River wasn't large enough to continue growth. Water is delivered to fountains and baths where citizens collect and use it. These fountains were very elaborate and quite large. And the other positive that these fountains did was, especially in warmer times of the year, it would allow mist and moisture in the air as it was splashing about through these fountains and actually cooling off the areas of the city. It allowed cities to grow in size. Water and food are highly important to life. And when you are spending most of your time being a hunter and gatherer, it's hard to develop culture, philosophy, art, science, math, recording history. Becomes a burdensome task because you are spending all your time trying to either find fresh water or find food. When you're able to do that and you have sustainability and a city is able to grow and society is flourishing, it's a result of having water and food at the basis. The history of the aqueducts, the first Romans had resources, as I said, was the Tiber and wells, but as water obtained from these sources were polluted because of the growth of humans and humans polluting things, that still happens today, the reason they had to find a new source of fresh water. Aqueducts were invented in order to bring pure water from the hills. The day the first aqueduct was assigned BC 313. The number of aqueducts was gradually increased, partly at the public expense and partly by munificence of individuals. So people were paying for it directly. Here's a blurry picture because I pixelated it when I spread it out. But the main point I want to show you is that you can see the waterway here, and aqueducts are so impressive that they would cut through hills, valleys, mountains, cross rivers and streams, and they would go through hills. A lot of them were underground. So this was all cut out and carved by hand and by hand tools. Okay. Here is another video that will be posted on Edmodo. Now, thinking about, these are some of the major questions that need to be considered when designing an aqueduct. Obstacles, as we talked about, the engineers run into when designing these: valleys, hills, keeping the water clean while it's moving. These challenges were overcome by creating these aqueducts, these tunnels, these filtration areas. Okay. And I would say today's modern version of aqueducts are a mass array of underground plumbing that ships water all around and removes it as well through sewage pipes. Here's a side view of the anatomy of an aqueduct system, starting at the source here, and the drop shafts, the settling tank. With water, things that are more dense will drop to the bottom and the water will flow. So it's almost a filtration process. Tunnel and shafts, tunneling through help create airflow. So as they move through, you have your arcades, you have your inverted siphon, which as long as this one side is higher here, the pressure is stable, it will move through these valleys and actually push the water up. And then the only downside here is the lead pipes. Even lead pipes were still used in the 1800s, but we'll get lead poisoning. Now, this link above is called for cargo bridge. Granted, you might be wondering, Mr. Taylor, why are we doing bridges? Now, the point of this is, this actually has to do with bridges, but you need to use the same type of reasoning that you would use with designing an aqueduct. Both bridge and aqueduct deal with physical obstacles that engineers need to overcome. So go ahead and play that. It's an enjoyable game. Now, just a few review questions that'll help you recap after watching the videos and etc. Okay, we're going to change gears now, and we're going to go with tunnels. Let's get this presenting to you. All right. Okay, tunnels. Tunnels are created by civil engineers. Civil engineers and engineering traded in the design and construction of public works such as bridges or dams and other large facilities. Once again, I have a video here that I recommend you watch. It talks about what engineers do. The other thing I would recommend is looking over this list. It shows the world's top size tunnels by type of tunnel, their location in the world, and their length in miles and kilometers. The thing that's impressive when you look at this list, a large quantity of the tunnels Japan has created is amazing. And then realizing how long some of these tunnels, like the English Channel Tunnel that connects England and France, is 31 miles long. Imagine being underground for 31 miles. Very impressive. Amazing engineering. History of tunneling. Early history is traced through mining, started prior to 2000 BC. Ancient tunnels were built for water supply and escape route from forts during wars. So like secret passageways. Pioneer Tunnel of Canal Age, constructed in 1666 through 1681 to connect the Atlantic and Mediterranean, lower European, Northern Africa area. The use of gunpowder was the first time it was used in tunneling there due to the importance of water transportation. Canal system developed in England and other countries in the 18th century, leading to construction of a number of tunnels. If you go in the English countryside, there are all these small little like canal rivers that were built off main rivers to help with transporting goods. I was in England this summer and saw them. They're quite impressive, but they're all over the countryside for shipping things. So it's more efficient. And before cars and trains, tunnels carried only water, as we talked about with the Roman aqueduct. By the 17th century, tunnels were being constructed for canals. These canals, because we didn't have roads for cars and vehicles or railroads for trains, waterways were the highways to move freight over great distances. With trains and cars came tremendous expansion in tunnel construction during the 19th and 20th century. The development of railroads and motor vehicle transportation led to bigger and better and longer tunnels. If you ever had the opportunity to drive through any mountainous area in the U.S., there's a lot of tunnels. There's tunnels in the Appalachian Mountains in the Northeast. I grew up in western Pennsylvania, and there's quite a few tunnels around Pittsburgh. Today, not even mountains or oceans stand in the way. Okay. Some images of the evolution of tunnels. Okay. Now, some primary factors in selection: location, site. Parameters of curve and the gradient of that tunnel, the length of the line of that tunnel, balancing / work and cutting and banking of the tunnel, staple sites for ducts and tunnels. As a whole, these are things you have to take in consideration when preparing to design and build a tunnel. Now, primary factors in selection, the choice of tunneling method may be dictated by geological and hydrological conditions, geo meaning earth, hydro meaning water, cross-section length continuous tunnel, local experience, time / cost consideration. What is the value of time in the project? Meaning how long do you want it to take? Limit of surface disturbance. Say it's a subway. You're building already underneath a city that is developed. How is that going to affect the day-to-day functions of that city above? And many other factors, all right? This has been a recap. Thank you for watching. And once again, the video links will be on Edmodo. Take care.